to my YouTube channel. I am Hajra Mughal and today we will be continuing our lecture series on MDCAT and ECAT preparation for physics. I am glad you are joining me and I look forward to helping you achieve your academic goals. Let's begin. Students, in our previous lecture, I provided a comprehensive list of topics that you need to cover to prepare for your MDCAT and ECAT exams. Please review that list and let's move on to today's topic. Today we will be practicing MCQ focused on work, power and energy. So let's get started. Students, to excel in multiple choice questions on work, energy and power, please review the following essential topics: work energy principle, conservation of energy, work and energy, kinetic and potential energy, power and friction. Let's go through some practice questions to reinforce your understanding of these concepts. In force and displacement graph, area under the curve represents. So the options are potential energy, work done, power and change in energy. From the definition of work done, we can see that work done is equivalent to the dot product of force and displacement. So from this graph, it is easily clear that the force and the displacement curve, the area under the curve shows work done. So correct option is B, the work done. A bag is dropped from the top of a building 15 meter high, and at what height from the ground its velocity will be 14 meter per second, and these are the given options. So let's make a scenario that there is a ground, let's say the ground, and the height of the building is 15 meter and a bag is dropped from this height. So let's say at this particular height the velocity will become 14 meter per second. So you have to calculate this height, and let's say this height is h2 and the given height is, let's say, h1. You must have started in your previous classes that whenever anything is on height and it is under the influence of gravity, so it has a potential energy, and when you throw that particular object with some particular velocity, so that potential energy is converted into kinetic energy. So we are going to use the formula that loss of potential energy is equivalent to the gain in kinetic energy. So the formula of potential energy is mgh, but we are going to write like this because the one height is given and one is unknown, and the kinetic energy is half mv square. After cancelling out the masses and substituting the values of in the formula, that gravity is 9.8 and the height is h1. h1 is given 15 minus h2 and half 14 square. So students, tell me what is the square of 14? So it's 196, and when you cancel out it with the 2, so it will be equivalent to 98. So when you divide 98 by 9.8, sorry, it's 98 by 9.8, so it will be equivalent to 10. And when you take 10 on that other side and h2 on the other side, so it will be equivalent to like this. So the final answer is 5 meter, which is option number B. Work done by a force will be maximum when applied force is dash to displacement, and the options are parallel, perpendicular, 45 degrees and equal. So by the definition of work done, we know that work done is the dot product of force and displacement, and when we open this dot product, so there will be a trigonometric ratio, that is cos theta, and cos theta gives you maximum answer at 0 degrees. Cos 0 is 1. So it is equivalent to FT, and the work done will be maximum. So which option is correct? Remember students that whenever there is a term parallel, so the angle between the two physical quantity will be 0 degrees, and perpendicular means 90 degree. Usually we can use the term normal, orthogonal instead of perpendicular. So at 0 degrees the answer is maximum, so the correct option is parallel. Two bodies having velocity ratio 2:3, what is the ratio of kinetic energies? And the given options are 2:3, 9:4, 4:9, and 3:2. So we know that the formula of kinetic energy is half mv square. So if I take the ratio of kinetic energies, so it is half mv square. Half m will be cancelled out, and the velocities are given as 2 square over 3 square. So the 2 square is 4 and 3 square is 9. So the correct option is 4:9. Energy stored in a compressed spring is potential energy, kinetic energy, flow energy, and elastic potential energy. So when a spring is compressed or stretched, energy is stored and it is called elastic potential energy. So the correct option is D. The same, there is one more MCQ, and the nature of the MCQ is same, that energy stored by water in a dam is, the options are same. So we know that dam stores the water at some particular height. So the energy stored is potential energy, because the formula is mgh. So the correct option is potential energy. A man holding 10 Newton weight in his hand moves 5 meter horizontally and 10 meter vertically. Find the work done by the man. So let's make a figure that a man holding a weight of 10 Newton and the direction of the weight is downward, and it moves 5 meter horizontally and 10 meter vertically. So according to the definition of work done, it is a dot product of force and displacement, and when you open the dot product, so there will be a trigonometric ratio cos theta, and we know that the cos theta gives you maximum answer at 0 degrees and cos gives minimum answer at 90 degrees. So we can see from the figure that horizontal component makes angle 90 degree with the weight and 180 degree with the vertical component. You can use 180 degree means they are anti-parallel to each other, or you can use 0 degree as well, because both give same answer, but there is a difference of minus sign, but there is no minus sign in any option, so we can use any of the angle, either 0 or 90 degree. So we can conclude that the work done with the horizontal component gives no work done, because there is an angle of 90 degrees, and the work done with the vertical component, when we substitute the values, the weight, which is force, is 10, and the displacement in a vertical component is also a 10 meter, and cos 0 is 1, so 10 into 10 will be 100 joule. So the correct option is C. The product of kinetic and potential energy of a body is 4. If the mass of the body doubles, then the product will become, and the options are given. So the given condition is the kinetic energy and the product of potential energy is 4, and if the mass is doubled, then what will be the product? So we know that the formula of kinetic energy also contain mass, which is half mv square, and the formula of potential energy also contain mass, which is mgh. So if the mass is doubled, so the kinetic energy will also double and the potential energy will also double. So basically it will become 4 times kinetic energy into potential energy, and the product of kinetic energy and potential energy is also given, which is equivalent to 4. So 4 into 4 will be equivalent to 16. So correct option is C. Kinetic energy of a pendulum at its mean position will be. So students, look at here. So let's suppose I am going to draw a diagram of a simple pendulum. It's a simple pendulum, and this point when it is at rest, so this point is known as the mean position. And when you take the bob to one extreme position and when you release it, so it will move to the other extreme. So these 2 points are the extremes positions. This is also a extreme positions. So basically the question is, the kinetic energy of the pendulum at its mean position will be this. At this mean position, what will be the kinetic energy? So the students remember that the velocity of a pendulum is greatest at its mean position, where its kinetic energy is maximized. Conversely, the potential energy is greatest at the extreme position, where the pendulum comes to a brief standstill and reaches its highest point, thereby maximizing its potential energy. This transformation between the kinetic and the potential energy occurs as the pendulum oscillates between its mean and extreme position. So students remember, at the mean position, kinetic energy is maximum because at this point the velocity is maximum, and the extreme positions the potential energy is maximum. So they have asked for the kinetic energy, so the C option is correct. A bull is pulling a cart with a 2k Newton force and velocity is 1.5 meter per second, and you have to find the power. So the force is given as 2k Newton force, and k means 1000, so 2 into 1000 will be 2000 Newton, and the velocity is given as 1.5 meter per second, and you have to calculate the power. So we know that by the definition of the power, that power is the ratio of work done and time, and work done is equivalent to force into displacement per unit time. So if you solve this, that displacement over time is velocity, so there is one more definition of power, that it's a dot product of force and velocity. So force and velocity both are given, so when you multiply 2000 into 1.5, so it will be equivalent to 3000 watt. The unit of power is watt. So the correct option is B. Kilowatt hour is the unit of energy, power, temperature and time. So let's see students, that kilo is a number, 1000, so we can omit it. Watt is the unit of power and hour is the unit of time. So what is the product of power and time? So we know that according to the definition of power, it is equivalent to work done per unit time. And we know that the unit of work done is joule, and we can also write it like energy per unit time because they both have same units, or you can say same dimensions. So when you take T on the other side, so power into T is equivalent to energy. So the product of power into time is equivalent to energy. So kilowatt hour is the unit of energy. A stone is thrown vertically upward with a velocity of 14 meter per second velocity. At what height the kinetic and potential energy will be equal? So students, there is a given condition that kinetic energy is equivalent to potential energy, and kinetic energy is half mv square and potential energy is mgh. After cancelling masses, the remaining quantities are these, and we have to calculate the height. So separating height, it will be half and g will be in division in v square. So after substituting the values, half g is 9.8 and the v square is 14 square. So we know that this v square is 196. When you cancel out 196 by 2, so it is equivalent to 98. So 98 divided by 9.8 is equivalent to 10 meter. So the correct option is C, 10 meter. Thank you students, subscribe to our channel and click the notification bell to stay updated on our latest content. Our next video will cover circular motion multiple choice questions as the part of our MDCAT and ECAT series. Thank you so much.